Right, the next three-dimensional object that we're going to look at volume for is a sphere. Now, a sphere isn't like any of the previous shapes that had consistent cross sections. A sphere has different cross sections no matter how you cut it, throughout the object, unless you were cutting, on an angle, I guess, not parallel. But either way, sphere basically, you're going to have it's equivalent to kind of like a three-dimensional circle. Okay, it's any cross section that goes through the center is going to be circular. And so the volume for this sphere is calculated with the formula 4/3 pi r cubed. And now, how do you remember any of these formulas, right? Not that I would necessarily make you, this one I would give you on a test, but if you needed one, one thing I do to remember these things, your circumference, area, and volume. If you think about circles and spheres, sphere being a three-dimensional extension of a circle, the circumference of a circle, 2 pi r, area is pi r squared, and volume is 4/3 pi r cubed. So you're increasing dimension, right? Circumference is a length around the outside. Area is a two-dimensional space on the inside of a circle, and volume is three-dimensional space that fills the sphere. And so as you increase in dimension, you increase in the power on the radius, right? R squared, r cubed, dimension 1, dimension 2, dimension 3. Also, they all have a factor of pi associated with them, which is very fascinating. And also they have this extra numerical factor, either a 2, a 1, or a 4/3. And now where the 4/3 comes from is a longer discussion that we're not going to get into. But that's kind of how, there's patterns to these things. But anyway, so this 4/3 pi r cubed is the volume formula for a sphere of radius r. And so let's put that to use. Here I have an ice cream cone. We're going to call it an ice cream cone. It's a conical shape, like a waffle cone, 6 inches tall, so it's a relatively tall cone. 1.5 inch radius, and a scoop of ice cream that sits very nicely. It's a hemisphere, or half of a sphere. Sits very nicely, fits perfectly in that 1.5 inch radius on top. And so I want to find the total volume of ice cream, which is essentially the volume of the cone added to the volume of the hemisphere. Okay, so first of all, let's calculate the volume of the hemisphere. So volume of the hemisphere is exactly 1/2 of the volume of the sphere, which is 4/3 pi times the radius squared cubed, which is 1.5 cubed. Now, I could just punch this in my calculator. I do know that 1.5 is actually 3/2. I could do a little bit of canceling actually, which is kind of nice. Maybe I'll do that instead of punching it in the calculator. 1.5, so that's 3/2, and I'm cubing it, so it's really 3 copies of 3/2, right? Just kind of thinking about this in factor form, because now I can do some canceling. This 3 and this 3 cancel, this 4 with these 2's cancel, and so basically I have 9 on top, a 4 on the bottom, and a pi. So that equals 9 pi over 4. We could say 9/4 pi. Okay, so there's our volume. Now, of course, I could punch that in the calculator to get an actual decimal value for that. So this is approximately 7.07 if I would round to the nearest hundredth. Okay, not too bad. So again, that is 1/2 of the volume of the sphere. Then let's look at the volume of the cone. And the volume of the cone, remember, is going to be this base area of the circle times the height of the cone. So the base area is, oh, and then, sorry, it's also 1/3 of that, right? So volume of a cone is 1/3 pi r squared, that's your base area, times the height of that cone. And so r squared is the 1.5 squared, so we get 1/3 times pi times 1.5 squared times 6 is our height. Oh, I should also put some units on this. These are cubic inches. Okay. And then, again, you know, I don't like working with decimals personally. If I was to square a decimal, I've got to do 15 times 15. Anyway, I like working with fractions. That's 3/2 again, right? And so 3/2 squared is 3/2 times 3/2. So what I'm looking at is 1/3 pi times 3/2 squared, which is another 3/2, times that 6. I would cancel 3 and 3. A 6 over 2 creates a 3 over 1. And so what I'm left with is 9 pi and a 2. So that's 9 pi over 2, or 9/2 of pi. Now, of course, the decimal value for that, oh, it's interesting, it's half of that. Huh. Well, that's kind of cool. 9 pi over 2, which is approximately 14.14 cubic inches. Now I'm just going to double check to make sure I didn't make any sort of mistakes in there. Looks good. Yes. Just running them through. Nope, that looks perfect. Okay, excellent. Okay, so I get those two values, and then, oh, it's not half, it's double that, double that volume. And then my final volume is going to be the sum total of those two, right? So volume is equal to 7.07 plus 14.14, which would give me 21.21. Yes, 21.21 cubic inches. Okay, that's the total volume of ice cream packed into that solid there, the cone and hemisphere combination. If you want to do this in exact form, you could do 9 pi over 4 plus 9 pi over 2, which the 18 pi over 4 be 27 pi over 4, I believe, in exact form. 27 pi over 4, let me just double check on that, should be 21.21. 27 pi over 4 is 21.21, there it is. So that's pretty cool. Anyway, so there's our total volume, and again, it's just adding half of a sphere's volume plus the cone's volume to get the total volume of ice cream that's present.